Okay, here we go with solving systems algebraically. Basically, it is solving by two different methods, methods that you've done before. I just don't know if you've been calling them the exact same thing that I'm going to call them. But it is substitution or linear combination, which I like to call elimination. Now, before we get started, I want you to kind of look over this, and I'll kind of work your way through it. That should be an equal sign there. Two concepts here that I'm going to put in a 4 wherever I see y. And what that's going to do is it's going to take care of one of my variables and leave me with just x. And if I were to simplify that, I should be able to solve for a value of x. So x is equal to 1. So that's actually substitution in itself. We're just not going to substitute a number. We're going to substitute it in a new equation. The other thing I wanted to make sure that you remember that when you're simplifying an expression like this, make sure you distribute first. And then combine like terms. So I'm going to add 10 and get 7x is equal to 7 divided by 7 and get x is equal to 1. Now, the fact that they're both equal to 1 is just coincidence. But that is your idea there. So, solving by substitution. Solving by substitution means that you need to take one of the equations, it doesn't matter which one, and you want to either solve for y or x. Now, I'm going to pick y because I think I can take this equation right up here at the top and I can write it as a function of just y in a couple of quick moves. I can add y to both sides and subtract 13. And what I mean by solve for y, I don't mean you'll get an actual answer for y, but you're going to get a new equation for y, or rewrite the equation. And the substituting comes right here where I'm going to take this 2y, I'm going to replace the y behind it with 3x minus 13. That was the purpose of taking the top one and solving that for y. I got it by itself. And the reason why I picked y is because there's a 1 in front of there. I'm not going to have to divide by anything in the end. Okay, just kind of out of convenience. So now my second equation, I'm going to take 2x. I'm going to put plus 2, but now where this y is at, I'm going to replace it with 3x minus 13. And this is why I had you practice some distributing right away. And some combining like terms. So I'll add 26, get 8x is equal to, like 8x is equal to 16 divided by 8, and get x is equal to 2. Now, it doesn't matter which way you do this, but x is going to be 2 regardless. So now to find the value of y, I'll put 2 back into one of my equations for x. I like that one because it's solved for y, so 6 minus 13, negative 7. So as an ordered pair, remember ordered pairs go x comma y, I get 2 comma negative 7. So x was 2, y is equal to negative 7. To solve this means we've got both of those numbers. If I were to solve this by graphing like we did the other day, if I were to graph them, they would cross at the point 2, negative 7 on the x and y axis. Okay, so that is solving by substitution. That linear combination is what I call elimination, and the reason why I call it elimination is I am trying to get a variable to eliminate. I'm going to add or subtract so that the 2 x's go away or the 2 y's go away, or maybe it's both. But in order to do that, I need to have opposites. And by opposites, I mean this. Opposites are like, say, negative 3 and 3. Because when I add them together, I get 0. Well, one's positive, one's negative, but they're the same value. I look at here, I got a negative 1, but I got a positive 2. So what I'm going to do is I'm going to take the top equation, I'm going to multiply it by 2, and I'll just rewrite that as 6x minus 2y is equal to 26. I'll leave the second equation alone. I'll leave it as 2x plus 2y is equal to negative 10. So now that when I add these, I get 8x, but the negative 2 and the positive 2 add together to give me 0 y's. Add these together, I get 16. Divide by 8, and I get x is equal to 2. Okay, now how do I get a y value that goes with it? I put x of 2 into either one. I'll pick the bottom one. And I am going to solve for y. Subtract 4, 2y is equal to negative 14. Y is going to be equal to negative 7. So again, I get 2, negative 7. If you're thinking that looks familiar, well, it is, because it's the exact same problem we just did. I just solved it in a different method. Will you have to do both methods? Yes. At least once. You have to prove to me that you understand elimination. You have to prove to me that you understand substitution. But after that, you pick whatever method you feel best at. And I would suggest practicing both because certain situations are better than others. Like, for example, I like the elimination on this particular problem because it was very easy. Just had to multiply one equation by 2 to get opposites with the y's. You might sometimes have to multiply both equations. For example, if I wanted to get rid of, say, the x's, I would have had to turn them into 6 and negative 6. So I would have to multiply the top one by a number and the bottom one by a separate number. But you need to get opposites. So here we go. Solve the system by whatever method you pick. I'm going to pick, just for the heck of it, substitution on this one because it's easily solved for y. So I'm going to add 3x. And I got y is equal to 3x minus 5. That will go up into the second equation. So 9x minus 3, 3x minus 5 is equal to 15. Distribute, I'll get 9x minus 9x plus 15 is equal to 15. Those will go to 0, so 15 is equal to 15. Yes. There's no more x's, they're gone. What this means is I'm actually dealing with the exact same line twice. So there is an infinite number of solutions, or many solutions. Okay, that's what it looks like if you're doing substitution. If we were to do elimination, it would be like I would collapse both sides and they'd be equal to the same number. But this is true. 15 is always equal to 15. So yes, it's infinite many solutions. Okay, I'll check the second one here. I'm going to multiply the bottom one by, let's go 2. And what I'm trying to do is I'm trying to get the 6 and the negative 3 to be opposite. So the bottom equation is going to turn into negative 6x plus 4y is equal to 14. The top one will stay exactly the same. But now when I add, the x's go away and the y's, and I get 0 is not equal, definitely not equal to 28. So there is no solution. And if I were to solve by substitution, you'd end up getting something where 0 is equal to, not equal to 28. Maybe it's a different number, but where one number is not the same as the other number. Now that only works the infinite many solutions, and the no solution only works when your variables were to go away. Here we go. Let's go with an application. We tried to solve the last one by graph and it didn't go so hot, but let's say a citrus fruit company plans on making 13.25 pounds of gift boxes of grape, oranges, and grapefruit. Each box has to be retail value of $21. Each weighs 0.5 pounds and the retail value of 0.75, while the grapefruit weighs 75 pounds and has a retail value of $1.25. How many oranges and grapefruit boxes must be included? So let's go. X equals the number of orange boxes. Y is the number of grapefruit. Okay, I'm given the total poundage, so I'm going to see how much weight is given by the oranges, and I'll multiply by that, 0.5x where the grapefruit weighs 0.75, y is the weight of the orange boxes, the weight of the grapefruits, they got to be the total weight. So if I'm thinking about units, it's pounds, adds up to pounds. The other one is I know the total value of the box, $1.25. So I'm going to have to take the price per orange and multiply that by X, $0.75 will give me X. And then 50 cents, or no, let's see here. Oh, I grabbed my $1.25 in the wrong spot. That was pretty cheap. That should add up to be the total of 21 bucks. Okay. So, if I were to solve this, I would go by solving by substitution. Well, sorry, not substitution, elimination. And I'm going to make the x's go away, or the y's go away. And doesn't really matter, but let's say it's the x's. I want to create an opposite. And to create an opposite would be that I'd take one of them and multiply it by negative 0.75. Why negative 0.75? Because this is a positive 0.75. So on the bottom one, we'll multiply that by positive 0.5. So my top equation, multiply those out real quick, would be negative 0.35. Okay, 0.75 times 0.75. Good. Seven. Okay, make sure that's negative. Okay, now on the bottom one, 0.5 times 0.75. 0.5 times 0.75. And I missed a number in there. There should be a 7 in there. Okay, and then plus 1.25 times 0.5. 0.625y equals 21 times 0.5. So I'm just going through and I'm multiplying those out. So those are going to cancel out. Here we'll have 0.625 minus 0.5625. Okay, and then 10.5 minus 9.9375. Okay, divide that out, 0.0625. Okay, and it works out to be y is equal to 9. So what that tells me is y is that there are 9 grapefruit. To get x, I'll take 0.75x plus 125 times 9 equals 21. So as I'm multiplying these through, make sure that your answers are realistic. Like, for example, if we're talking about oranges and grapefruit, you're probably going to get whole numbers. And chances are that if something did go wrong, maybe a decimal got hit wrong or wrote down, like I here botched the 7 being there, so that would have messed things up completely. But it ends up being that there's 13 oranges and there's 9 grapefruit. All those crazy weird decimals ended up working out to be whole numbers in the end.